So good afternoon, everyone. This is Dinesh Raghu, is going to present on behalf of Excel Design Technologies. Today we are going to see about some interesting topic inside the SolidEdge, which is none other than the SolidEdge simulation, and we'll just discuss on the static analysis capabilities we do have inside the SolidEdge simulation today. So I'm just taking an example of our customer master mover. I just show the relevant image of our customer's CAD model. So you can see this is a CAD model. This is a CAD image of what the master mover customers has created. They have created all their parts using our CAD model, and they have also analyzed their strength of the clamping arm and the material using our solid simulation. I hope you can see that this is master mover which is used to move any heavy loads in a terms of a easier manner, be it a wind turbine blades or even a London buses. So it can move it on a heavy, easier manner. But here we are going to focus on the lighter duty loads, which I have displayed on the screen. So the idea is same. Nothing doesn't change. Idea is the same. Clamping mechanism, which transfer the weight of the load onto the axle for the traction. This remains the same, and we are going to assert a clamping arm of this particular master mover variant for the rated condition of 150 kg. So we can explore today about those in the solid edge static simulation. So once you finish creating the clamping arm inside the solid edge, you can start up with creating the study, which is the first step. And after creating the study, we have the geometry to define the geometry which is going to undergo the analysis. And for creating the structural loads, body loads and thermal loads, we have a separate load conditions here. And if you wanted to constrain any of their degree of freedoms by pinning it and fixing it and constraining its rotation, we have the constraints. And for creating a mesh for 3D, 2D and 1D elements, we have the mesh, and we can end up with solving of the same. So I just go with the first step of creating the study. So we can it has a range of studies from static analysis and normal mode analysis, buckling analysis, etc. So today we are going to explore about the linear static analysis, and the mesh type which I am going to see is 3D elements. Since I am using a 3D element, I'll just go with the tetrahedral element. And if you are going with the surface mesh, that is 2D mesh, we have the surface elements. For general bodies like 1D, 2D and 3D combined, we have the general body studies. So we have the advanced options like iterative solver and large displacement solver for the nonlinear analysis, which we can see in the upcoming sessions. So here I'm just been assigned the default of aluminum cast, but if you wanted to change its material properties, for example, I wanted to bring those aluminum 1060 material property to my geometry. I'm just applying it to the model. Before applying, I'll just showcase its density property and also the modulus of elasticity of the material, which has been mentioned, and the yield strength of 27.579 megapascal. So these are the basic prerequisite for any static analysis to go with. I'll just apply the same to the model, and you can see that its properties and its visibility status also apply to this. So once you have done with defining the material and also the analysis type, you can define the geometry. So these are the geometry which I am going to make use of in the analysis. I have defined the geometry, and the next thing, once you are done with that, defining the geometry which is going to get analyzed, you can bring the force of 150 kg Newton by using your structural load conditions. We have the structural load conditions under which we have the force to the selected entities and the pressure condition, and we can apply the hydrostatic pressure, and we also apply the torque, displacement bearings, etc. So in these conditions, I'm just going with a force condition of 150 kg force, which is I'm going to apply on the place where the fasteners have been tightened up. By clicking on the conditions, and once you click on this, I am just going to apply the 1500 newtons of force in this direction. And after applying the force of the rated conditions, you can go to the constraints where I'm just can constrain all the 6 degree of freedom using a fixed mates, or you can constrain its 3 transitional degree of freedoms using our pinned mate, or if you wanted to constrain only the rotation, you can also make use of the cylindrical meshes. But in this condition, I am just giving the fixed constraint to constrain these two faces. So where the material is going to tied up, I'm just constraining these faces, and we are done with the constraining amount also. So the next thing which I'm going to do is all about the meshing the overall body. So here I have initially discussed upon the three types of meshes: 1D element, 2D element, and 3D element. And since it is an 3D object, we'll be using the tetrahedral elements which has been given by our solver to solve on the same. So we are going to select the body, and we can select the type of meshes, out course you wanted, and how many elements that should surround around a circle, and the minimum element size factors, and also the growth factor. I'm just clicking on OK. I'm giving the mesh. Since I have given a coarse mesh, you can see that the elements are getting space in a coarser manner when compared to when you are giving finer mesh elements. So I'm just clicking on solve. So we have the NX Nastron solver, which is a way superior solver, uh, which comes along the Siemens solid edge product. This helps you to give the more accurate results when compared to many solvers in the market. So once you finished up with the condition, you can see that we have obtained results. We have applied the stress condition where I am making use of the von Mises condition, and I am just animating the result. You can see that it's a saturated result. If you wanted to bring it in the actual deformation scale, you can just see the actual deformation which has been in a real time. So I'm just giving on the stress condition, and I will just, you can see that it's well within the reach of our yield strength, and I'm just going to assess the displacement too, so which is also in micron level scale. So I'll just animate the same on this. You can see that the displacement varies from the top to the bottom in this condition. So thus by you can analyze its stress and displacement properties of any other material inside the solid edge simulation. This is the initial video I just wanted to start up with. In the next upcoming section, we can see about the buckling analysis and the normal modes of the solid edge simulation model. So that's it all from my end. So if you have any suggestion from your end on the next video, you can drop on the same. So thanks guys, thanks for following us.